video, what we saw what is sampling distribution of mean and what is, the distribution of the sampling distribution of mean when your original population is normally distributed. But we are interested in when our original population is not normally distributed. So we have something called central limit theorem, which is very important theorem, and we call it as, like, for the short form we call it as CLT, right? So we'll be looking at what is central limit theorem, and then we'll be looking at the visualization of central limit theorem. Of course, there are mathematical proofs also for central limit theorem. So what is this theorem? This theorem tells you that if x bar is the mean of the random sample of size n, so basically x bar is your sampling distribution of mean, right, as we discussed in the last two videos. Okay, so if x bar is the mean of the random sample of size n, okay, taken from a population which may not be normally distributed but whose mean is mu and whose standard deviation is sigma square. So you have a population whose mean and standard deviation you know. Then for large samples, n goes to infinity, x bar has a normal distribution with mu mean, the same mean, but the standard deviation will be divided by square root of n, where n is your sample size. So in a way we are saying that if you do x bar minus mu, which is the mean, divided by sigma by square root of n, that would be a standard normal distribution as n goes to infinity. And from the calculations we know that n greater than equal to 30 works. So here in this picture you can see that I have I have a probability distribution which is denoted by red is my probability distribution, so that's my population, right? And then what I'm doing, and this is the mean of my population, here is the mean of the population, you can see this is the mean, right? And then this yellow one is one sample per mean. It means that I have just taken one sample, so that is nothing but, this yellow is nothing but my original population. Now if you take 10 samples per mean and then you plot the sampling distribution, the green one you get, okay, you can see that it is turning to be normally distributed. And then if I instead take 100 samples, then I plot the sampling distribution of the mean, I get the blue one. Can you see? That is a normal distribution. You can see that that's a normal distribution with the mean equal to the mean of the population. Can you see that? Right, so that's the idea of central limit theorem. We are not going to prove it, but I have a MATLAB code, so I would like to show you, right? So what happens, so let me just take out my MATLAB code here. Okay, so here first I am taking the binomial distribution, so I'll take the binomial distribution. I am running my code, okay, and you will see in a moment there will be a code. Okay, so in a moment you will see a window. Can you see? This is my binomial distribution. On the top you can see the sample size. As the sample size increases, it's 20 now, you can see that we are coming closer and closer to the normal distribution. Can you see? So I have taken till 100 samples, right? 100 sample size. Okay, so total sample, like number of times I did my experiment is 10 to the 5. Okay, so here you can see that you are coming closer and closer to the normal distribution for the sampling distribution of the mean, although your original distribution is a binomial distribution. And then I would like to show you for the same thing, I would like to show for an exponential distribution. You see, this was my original distribution. Okay, n equal to 1, you'll get your original distribution. And then the sampling distribution of mean with different samples, right? Sample size here it's 35, 37, 39, 40, 43, 40, like it's running out. So you can see that as your sample size increases, you are coming closer and closer to the normal distribution, right? So that makes sense. So that's your CLT, right? That's your central limit theorem. So now I would also like to show you, I am just showing for some like distributions which we use very often. So here is my gamma distribution. So you can see that what happens to my gamma distribution, right? For the sampling distribution of the mean. So you understand the difference. Once one thing is your original population, which is a gamma distributed population, and then you have the sampling distribution of the mean, right? And then you increase the sample size, and as the sample size goes to infinity, which generally is n greater than equal to 30, you get a normal distribution there, and then you can apply all kind of results on that kind of distribution, right? That give you some insight into the original population. So let me show you what happens if we actually take the normal distribution only. So suppose your original population is also normally distributed, then obviously we were expecting this thing. We saw it in the last video that the sampling distribution of the mean is normal irrespective of the sample size, even for the sample size 1, 2, 3, 4. So the sampling distribution of mean is normally distributed. So if the original population is normally distributed, then you don't have to worry about the sample size. But if the original population is not normally distributed, then you have to be sure that your n is greater than equal to 30 for you to apply these results. Okay, so let me show you for Poisson distribution also, because that also we use like very often. Okay, so we have the Poisson distribution here. You can see this is my Poisson distributions for different n's. Okay, as n increases, I'm getting a normal distribution for the sampling distribution of the mean, right? So that makes sense. Okay, I hope you like it. And this is a very it takes some time for grasping all those things, like what is sampling distribution of mean, and then what is the central limit theorem. But these are the foundations for your hypothesis testing and all those things. So I'll show you one last, which is uniform distribution. Okay, so we can start looking at uniform distribution. You see, this is how uniform distribution looks like in the beginning, and then the sampling distribution of the mean. As your n increases, you can see that we are getting close and close to the a normal distribution, right? So that was the idea of this video, that you should understand what is the central limit theorem. And of course there are mathematical proofs for central limit theorem, but uh, the visualization, like what is actually happening, that should be very much clear to you, right, instead of just the proofs. So I think that's it for this particular video. Okay, so I'll see you in the next video.